Hello everyone. In this lecture, we're going to talk about some trends and also some fundamental information about periodic table. So a periodic table is a very basic tool for chemists to understand the molecule materials, especially their physicochemical properties. That's a starting point, okay? So we will cover some basic trends for across the elemental, periodical elemental table. So let's first look at the valence electron configuration. For main groups, that's very easy. So like here, so that's main group from group 1, group 2, group 13 up to group 18. Then here, that's S block. And here, that's P block. Right. So for S block, you can see the valence electron just are identical as their atomic number, group numbers. So 1 for group 1, 2 S electron for group 2. And for group 13, so this digital here, so that's corresponding to the valence electron here, 2 S electron, 1 P electron. So in this case, group 17, so single digit here is 7, and it had 2 S electron and 5 P electron. Okay, and bottom here, that's a example for D block. Okay, so as you can see, and we can also use the group numbers to tell the valence electron for each groups. So group 3, we have 2 S electron, 1 D electron. Okay, and we have for group 4, we have 2 S electron, 2 D electrons, and in group 11, we have 2 electrons plus 9 D electrons. We have total 11 valence electrons. So as you can see, for D blocks, okay, the D block, the valence electron can be more than 8 because normally the D block, describes transition metals. So transition metal complex can have electron up to even more than 18 electrons in total, okay, valence electrons. But for main groups, S orbital, S block, and P block, so their valence electron normally less than, not more than 8, less or equal to 8, okay? And the next one, we'll talk about atomic radii. So atomic radii is also important, as I'm going to mention a little bit more at the end of the presentation, this lecture. So the trend here is, you can see the atomic radii labeled as these numbers below each element, each atoms. You can see for main groups, if we go from left to right, we will see atomic number decrease. Okay, if we go from top in the same group, okay, let's look at this one. You can clearly see the size, okay, the size from bottom to the top, it also decreases. Or in other words, from top to the bottom, it keeps increase. The same trend goes to other groups. If we look at the D block, you can say scandium had 161, titanium had 145, and all the way goes to here. So the trend is not apparent, but still we can see, a major trend is still decrease. Okay. But you can see zinc has and copper has a larger one than nickel and cobalt iron. So here there are some exceptions, okay? But the main trend is the same thing. But look at this, the period 3, yttrium 178. Let's say until to this part we have decrease. Here we have exception here, okay? So if we look at the same group, okay, and we will say the first low transition metal, the that's the this row, okay. If we group 3, you can say it's increase, okay. But if we after we move to group 5, we can say the second row, second row here, okay, and versus the third row here, they have comparable atomic radii, okay. So as you can see, the trend atomic size trend for D block is not clear as main groups, S block and P block, okay. So then next one we will talk about ionization energy and electron affinity for each element. So let's first explain what is the ionization energy. So ionization energy means for an element in its gas phase, so how much energy we need to pull one electron from its atomic state to give a cation. Oh, that's first, if you just remove one electron, so that's first ionization energy. If you remove second electron from A plus to this A2 plus, then we have second ionization energy. Then what is a electron affinity? Electron affinity is opposite. So you start from the atomic zero charge state, okay. So that means how when it add an electron, then how much energy it can give, okay. So all these two numbers, ionization energy, electron affinity, they are plus number, okay, plus number. They have plus sign, okay. Okay, and if we look at the two table here, see here, that's main group, and bottom one is that's D block. Okay, so if you look at the main group first, we will say the first row, okay, the first row here, okay, first row, okay, and we can say the number. So here it's a number, it's ionization energy. You can say ionization energy increase, okay, keep increase, okay. It's harder to remove the electron when we go from left to right, okay. Ionization increase, okay, in this way, okay. So same thing, we can see the trend for the second row increase, and primarily third row, we say almost increase. There's some small exceptions like these two, okay. If you look at the same group, okay, we can say the ionization energy in fact in this way is decreased, okay. Okay, and we look at the other group, it also has same trend, okay. So that's kind of has a consistent trend at their atomic size, okay. It's comparable. Then let's look at the D block. So let's look at the first transition metal, this row, okay, this row. we can say the ionization energy, we say keep increase up to this point. Then from group 10 nickel to copper, there's some exception here. This one is smaller than this one. Okay, let's go back a little bit. So you see this number is smaller than the second, but here it's larger. So that's still exception here, okay? Then secondly, the major trend that we see still keep increase, kind of like a main block, but the main group elements, but still a couple of exceptions there. If we look at the same group, scandium, yttrium, lanthanum, okay, you see the number decrease, okay, decrease. And for other, if you look at the other groups, we also see main trend is here is decrease, okay, decrease. But if we move, and we will see from here, from group 5, go this way, we see in the group 5, in fact it's increase, okay, increase. And the group 6, group 7, group 8, group 9, group 10, they keep increase for ionization energy. So as again compared to main groups, so D block, the trend is not very consistent, okay. So then here is another information about ionization energy. So for the same period, the second period from lithium to the fluoride up to Ne element, you will see the ionization keep increase. So that's a trend that we talked about before. But it's also proportional to the this unit. Okay, that's a Z effect divided by N, the square of Z effect divided by N. So Z effect is, we call it the effective atomic number. Okay, so you can say that's a trend. Okay, but you don't worry about. We will talk about more about what's the effective atomic number in senior course. Okay, but if you can learn that by yourself. But the main purpose here for this class, we want you guys to learn the trend, okay, for this ionization energy, okay. You can see the trend here for the third row transition metal in D block, half them up to mercury, okay, from here. We also see the mainly we see the trend is increase ionization energy, but we see some exception here, okay. But the main trend is keep